Okay, we're back at the home office. The map has processed, and we're going to take a look at the 2D orthomosaic first. This gives the builder, the contractors, a ton of information. Um, so this is the 2D orthomosaic geotiff. Um, yeah, came out quite nice. Zoom in. This was taken at 250 feet above ground level. Um, Everything looks really clean. You can zoom in on the homes. You can see around and just see an updated, very high resolution map of this area. And you can also measure distance. So let's say they need to know how much space they have from here to here. We can click on this distance tool, and we can actually measure from point A to point B. And we got a length of 611 feet. So pretty cool. Let's. We don't need to save any of this data, so we're going to delete that. And again, like here's a really cool feature. So I can put a marker anywhere on this map, and it's going to tell me my lat long and elevation. So any point on this map, I can give you latitude, longitude, and the exact elevation. And I'll get more into detail on how accurate it is here in a minute. But I just got to place a marker, and it gives me whatever I need. The tools, you got location, gives you your lat, long, and elevations, distance, area, volume. So let's say there was a stockpile here. I can trace around that and tell you the exact amount of volume of material you have. You can select the material, count, and issue. So if you see an issue, you can place an issue marker, or you can draw around an area. For example, let's just say we have an issue here. Whatever it may be. Let's say there's a manhole cover that has to be removed. You can write a summary of it, the severity of it, cost, repair, etc. So don't need to save that. So a lot of valuable stuff. So again, if we were to use our distance tool, and this can actually give us a distance, and it's also going to give us a slope. You can see which way the land is sloping. And it's sloping at 1.74% is the slope of the land going across. So that's pretty neat. Again, no need to save any of this information. So this is the 2D orthomosaic, and then we can also look at an elevation, and we'll look at terrain only because we're not worried about the houses. And exactly how my line that I drew here showed the pitch. Everything's pitching down. Here's the high land, and here's the low land in this area. So that's a lot of good information for the civil contractor, the earthworks. A lot of planning can go into this. A lot of different points. So if we zoom in, here's where I was set up. Here's where the base station was. Here's where I was, my van, my home point for the drones. My base was set up on a known point, sending corrections to the drones while they were in the air. Just trying to go over this as thoroughly as I can, but as short as I can also. So let's look at the model view. Now, all the photos here were taken nadir straight down, so I wasn't trying to build a great looking 3D model out of this, but The focal point here is the land, not the homes in this mission. So they're able to go in here in 3D and look at everything. And everything looks good. And again, you can use all your tools here. Distance, I can take a marker, tell you the coordinates and the exact elevation. Another thing we can do is look at elevation in 3D. So we pull this all back. You can see where your high points, your low points are. And, if this was an area that had a lot of elevation changes in it, I mean, that's where it really shines. Here it's pretty flat, but they still, to get pipes in, use this for design. Just a lot of things you can use this for. They can lay out, on this, you put this into their BIM in CAD software, they can lay out where all the storm drains, the sewer lines, the electrical underground. They can use this map and overlay all that info onto here. And it's the same with any type of construction project or mechanical project. Let's say there's a big rooftop on a building that a lot of piping and ductwork was going in. I can map that, and that geotiff and that point cloud can go into BIM 360, Revit, AutoCAD, and they can design all the piping and everything to go in there, because this is survey grade accuracy, and I'll show you that in a minute. But this applies, not just to land, new constructions, buildings, rooftops. I mean, you name it. The use cases are totally endless with this. And again, put it into your AutoCAD, BIM 360, and the BIM department can just go to town on designing things and where to put things and layout. If I had prints, I can overlay them onto the site, very easily. And with my exports, so can your BIM department or your CAD department do the same thing also. So what else do I want to look at? We can look at contours. Your contours are going to give you all your elevations. That's good. Elevations are very important, especially with earthwork. You need that detail. You need that knowledge just to even bid a job. So let's go into map details and get that accuracy I was talking to you about. So we're going to look at just an overview, our accuracy, X, Y, and Z. Let's go to the process report. So our average GPS trust, that's how much the software trusts the information coming in, is 1/10 of a foot. So right there. And then if we scroll down, you can see stuff like the medium shutter speed, 21 megapixels, 12 images per pixel, or 12 images per pixel. And then here we get to the RMSE, camera GPS location. So we're way better than 1/10 of a foot. 0.03 X, 0.03 Y, 0.03 Z. And there's another way. I've done this so much that I'm confident in these numbers, but if you need proof of concept, I can lay down checkpoints in the map and record those checkpoints with the GNS receiver and compare those checkpoints to our accuracy shown here, and it will validate the accuracy of the map. I didn't do that today, as I didn't need to, because I've already worked for this client before. They already know that everything's accurate, but if needed, that can be done just to validate the accuracy of the map. No issue whatsoever. And it's just more stuff with the quality report. you know. Um, I really like this stuff. It's cool. Just trying to think anything else I can go over with you. You know, here's the 3D. Uh, you know, we could look at the point cloud. It takes a while to load. I'm not trying to make this a long video, but if you know what a point cloud is, you know, here it's loading now. So let's just go back to the 2D map, and you know, see the high resolution of that, and just spend 1 minute talking about exports. So I can export out a GeoTIFF map. That's the 2D orthomosaic. It's one of the most highly used. Point cloud of this whole area. You know, it's a 3D point cloud. So your GeoTIFF map and your point cloud that's where your BIM departments are really going to take full use of this stuff. I can export elevation, a digital terrain model, a 3D model. You know, those are the best outputs. So try to give you an example. Your point cloud, I can export .las, .xyz, and Autodesk proprietary .rcp. So your two main ones we'll just take a quick look at. So your GeoTIFF, it's going to be in GeoTIFF. This will be exported in NAD 83 2011 Nevada East feet US EPSG 6521 US survey feet. That is for my area, Las Vegas, Nevada. Resolution max available 0.77 inches per pixel, and again this was flown at 250 feet AGL. If we were to fly it at 150 feet AGL, it's going to be a much higher resolution. And you have options on how much you want to export. You know, just I usually export is max available, but some people's software can't handle that, and I can reduce that file size. So again, this is Jeff with Building America signing off. Hope you enjoyed. Thank you.